In this section, we will discuss lipids. Lipids are the one class of large biological molecules that do not consist of polymers. The main functions of lipids include energy storage, hormonal regulation, insulation, and cell signaling. Let's review first the interaction between molecules and water by starting with the definitions of hydrophobic and hydrophilic. Hydrophobic molecules do not like water, so hydrophobic, while hydrophilic molecules love water. Amphiphilic molecules have a hydrophobic tail, which you can see here, and a hydrophilic head here. So one of its ends is attracted to water, while the other end is repelled. What molecule did we already learn about that was amphiphilic? Well, the components of the cell membrane are amphiphilic. Lipids are either hydrophobic or amphiphilic. One type of lipid is a triglyceride. Triglycerides are hydrophobic. They are constructed from two types of smaller molecules, a single glycerol, which you can see on the left, and 3 fatty acids, one of which you can see on the right. Fatty acids are carboxylic acids with a very long chain of carbon atoms. They vary in the length and the number and locations of double bonds they contain. So you can see the carboxyl group at the ends, but primarily we have this very long chain of carbons that sometimes have double bonds. To produce a triglyceride, 3 fatty acids, 1, 2, 3, are added to a glycerol to produce that triglyceride. Another type of lipid is a phospholipid. Phospholipids, like the phospholipid bilayer in a cell membrane, is an amphiphilic lipid. Phospholipids have 2 fatty acids, which you see in this greenish color, and 1 phosphate group. You can see part of the phosphate group here in that purple color. The phosphate end is polar, so this end is polar, and forms hydrogen bonds with water. The fatty acids are made of long chains of carbon and hydrogen, making them nonpolar. As a result, the phosphate end is hydrophilic and the fatty acid end is hydrophobic. Overall, phospholipids are amphiphilic.